Bezzenberger さんです。We'd like to invite our next speaker, Mr. Luis Bezzenberger. Mr. Luis Bezzenberger, the floor is yours.
Hello. Hello, I'm Luis with BrainBot, working on something called Shutter Network, which is a threshold encryption mechanism. I'm very glad that Maikara had this talk before me about MPC, because then you already know what kind of the gist of it, the higher level picture is as well. Threshold encryption is a subset of MPC, so but yeah, I'll be going into that later, and my talk will be less about the technology, more about the application. So I'll just be running through a lot of these use cases we're applying to threshold encryption and commit reveal cryptography. Commit reveal meaning you hide something and then you commit to something and then you encrypt and then decrypt essentially. So first of all, why is privacy normal? It's a sort of title of the talk. It's very simple on the high level. You just cannot do business without having privacy. Yeah? So if you run a business, you know that there is things that you don't want to expose to everyone. Otherwise, you just really lose your information. It's all about sort of the way you succeed with the business is you have some institutional knowledge and some information advantage over others. If you lose that, you're just going to make less money. And then I think this is I think the bigger point that people don't understand, that it's not really about idealism, but that it is about just necessity. And the other bigger point is I think pseudonymity isn't privacy. So people I think for Bitcoin, they think Bitcoin is private. It is not, right? You can just extremely easily uncover someone's identity just by if they do 2 or 3 transactions in a row, like let's say 5 or 6, you just connect the dots and you lead it back to that person, right? So pseudonymy is definitely not privacy. So I talk about privacy, but actually Shutter and this commit reveal encryption gadget is only partly related to privacy. It's only sort of like temporary privacy. So again, it's this threshold encryption commit reveal gadget. We have this distributed set of nodes that together generate encryption decryption keys. And we then apply this kind of encryption as a service sort of mechanism to different use cases. The major one that we've been generally focused on is the encrypted mempool, which means you encrypt transactions and have their order be finalized and be committed to by the sequencers or by the block producers while they're still encrypted, and only afterwards you decrypt. And that way we can prevent front running and real-time censorship. And that's built into Gnosis Chain, and we're now working on an out-of-protocol PBS implementation, and we're also gearing up to write an EIP to eventually make it part of the Ethereum L1 protocol. And we have, I think, a really cool draft design there that fits extremely nicely with ePBS and Fossil. But I won't really be talking about that today. I'll be talking more about those Shutter API, which is kind of this just API that provides access to our distributed threshold encryption decryption services. And I'm just going to be talking about those applications on top. And I want to make the case that you don't really see it, but commit reveal is everywhere, sort of. It is really, for trading and other use cases, really the backbone of fairness. You can really, if you think about this very simple example, rock, paper, scissors, right? If you play this game of rock, paper, scissors and a lot of other games like this, you, let's say one of the players reveals their hand before the other's hand and the other sees it, you immediately, the game immediately becomes useless because they see the other hand, they react to it, game is over, right? And that's just the most easy analogy, but this is kind of everywhere in trading and when you make decisions, when you submit let's say you have you have a bidding process, and you submit a bid to the process, and other people are seeing your bids, and they will react to the bid. In voting, right, if you see the other people's votes before, right, you'll be influenced by those votes. So it's really sort of like this thing that is everywhere and is needed because we make decisions, and we rely on other people's influence. We get influenced by those other people's decisions, and we want to ensure information symmetry by having this kind of regular sort of having everything hidden and then having everything decrypted at the same time. Usually you have a centralized party to do that, right? Usually you just trust the exchange mechanism, or you trust the voting the government, right, in real elections to make sure that the votes are kind of hidden. But that's not how we do it in crypto, right? We have this ability to do it in a decentralized way, and that's kind of what threshold encryption is. You can decentralize that centralized party that makes sure that things are orderly committed and revealed to, essentially. And you only have this trust assumption of k out of n nodes that need to be honest and don't collude, but then you can have this decentralized encryption decryption mechanism. So yeah, Shutter API kind of offers access to this in a very simple form, just with 4 sort of API calls, and those are some of the use cases. I won't really go into it. I'll just be running through the actual apps that we built. This is the API. Essentially, it's really just like the setup phase, and then you so the register identity, and then you get your key, the encryption key, and then afterwards you just get that decryption key. Essentially, that's the API. So it's super simple to use. The one thing that we've been building on it since a long time actually is shielded voting on Snapshot. So it's live since a couple of years actually now, and it has shielded many proposals, and DAOs like Arbitrum use it very successfully in their elections. And you can see, so here you can see how it works. Right? It's like, here it's already revealed, but you can see that it was protected by Shutter during the vote. So here the point is we have the results shielded during the vote, and then at the end we decrypt them, and that's again for information symmetry. If you vote, if you see what other people are voting during the voting process, you open up this strategic kind of gaming and bad malicious behavior during the voting process. And the next stage is really, so currently how this works is results are shielded and then they get decrypted and everything is transparent afterwards. But the next stage is also something that people are asking for really. Sometimes really desperately, or they really need it, right? They say if it's just shielded voting during the vote, it has little value. But yeah, so the next stage would be the results actually remain shielded, and or let's say individual results remain shielded. So obviously the outcome needs to be known, otherwise it's there's no impact from the vote, right? But individual votes are then still protected, and you have this higher level of anonymity this way. And the way we're achieving that is with a simpler form of homomorphic encryption. Sorry, there's a typo here. El-Gamal, not El-Hamal. Sorry, which is this form of homomorphic encryption that is only using addition. So it only works on addition, which is very efficient. Yeah, so Michaela said FHE is extremely expensive for everything multiplication, everything higher level. But for some voting types, you actually only need addition. So that's why we can kind of combine threshold encryption with this El-Gamal linear homomorphic encryption, and then we can keep everything encrypted while afterwards even, right? And that's how our very early POC there looks like. Essentially, so you see the encrypted ciphertext of the vote, or these like scalars or whatever, or the numbers, and you only have ZK proofs that everything is correct essentially. And afterwards you see the result, but you'll never see the individual from here, the individual votes. You'll never see the results, but you'll see the end result. In this case, the 4. Right? Yeah. So again, just a sneak peek, but hopefully we're bringing that to Snapshot at some point. Another fun thing here is this is a totally different application. This is just to time lock a gift, right? So we encrypt a private key in this case actually with the shutter keys, and we just send that out, and we can time lock a gift, in this case a Hongbao for a Lunar New Year. Yeah, that's just another application of commit reveal, of kind of this time lock encryption and commit reveal in cryptography. And this is another one where what we built is essentially, we call it shutter predict. So it is a way to publish an encrypted prediction about the future, or something that maybe also something like information that you know that you don't want to reveal, but retroactively you want to prove that you had access to this information. So people do that with hashes today. You see here Kobe has leaked some information back then about the FTX, upcoming FTX hack. He posted the hash, and then sort of like a month later, 2 months later, he revealed that he actually knew some insider information about that. Sorry, that was about CZ. There was another one about FTX. This was about Binance. Yeah, so that is cool with hashes, but it's not really accessible, right? Kobe knows how to do it, but maybe not everyone knows how to do it. So we built an app to do it. And the other advantage of using threshold encryption is you can actually enforce the reveal, right? So with a hash, the person who predicting it can just choose not to reveal the information, whereas with threshold encryption, it forces you to. There is a high commitment to that, because the key will be revealed, and if the ciphertext is public, everyone will be able to see it. So it enforces the reveal and makes you really like commit to that prediction and commit to that thing. Because otherwise you can just spam all kinds of like interesting like fake information or fake predictions. Not if you actually and then only selectively reveal what actually happened, right? Whereas if it's encrypted, and then later decrypted, you have a higher commitment, right? And then we have this Twitter bot that just releases the prediction. So there's one cool example here from a community member, Sky, who made a prediction about the Optimism's future key experiment, and then it got decrypted later, and he was actually 100% correct on his prediction. But yeah. Shutter for Claros juror voting is coming very soon. So that's essentially the same principle and the same problem as in the voting case, and especially heightened in Claros because they have the game theory there works in a way that it incentivizes to vote with the majority. So if you see the results before the vote has ended, you just encourage people kind of just hopping on the bandwagon and just voting how everyone votes. And that really breaks the game theory and incentive mechanism. So we're super happy that Claros are implementing Shutter, and that's actually already in beta out. Is it not even coming soon? It's actually just went live, I think, 2 days ago in beta. Here's another small one. It is a sealed bid RFP, request for proposal process. So you can submit, you can create a request for proposal, and then bids can be submitted, and they will again be encrypted with the Shutter keys while the RFP is going on. Again, so that you can prevent this like bidding war or something, right, between different bids. I think this is cool for DAOs or even traditional companies who want to issue these RFPs. Here's another one about sealed bid auctions. In this case, specifically for bonds. And the funny thing is that's actually how the US government issues treasury bonds, new treasury bonds. In this, yeah, you just, everyone submits sealed bids, and then you have this and then you reveal that you after 2 weeks or something, you reveal them and you fill it up until the yield, the sort of highest acceptable yield is reached for the government. And we built this as a little POC on Gnosis chain here. We think it's actually that's actually a really cool way to issue new bonds, but could also be used for tokens or anything else. But yeah, so we know especially that it is a good way to issue bonds, because again, the US government is doing it exactly that way, right? And here's kind of like a little bit of a bonus. So we build all these apps, right, or dApps, but actually, as we just saw in the talk before, AI is coming, and in some way, dApps are dead, and long live MCP. If you're not familiar with MCP, so MCP is the Model Context Protocol from Anthropic. So it is this way how you can add tools and plug in sort of your own API, essentially, into your own personal assistant, your own AI assistant. And I think that's especially powerful for something like Shutter and maybe other also like more complex cryptography and crypto applications, because they really make it accessible, right? They really give anyone the power to use this type of advanced cryptography, and you can just use it from your Claude in this way. This was ChatGPT here. They just open up developer support, but in Claude it works better. So essentially, you just talk to your Claude and you say encrypt something, and then it calls the tool and encrypts it for you. Gives you the hash. It gives you the ciphertext, gives you the identity, and tells you everything you need. And you can ask questions as well. You can people who maybe it's a complex technology, right? You can just ask it now, what is actually happening, or what do I need to do? What's the next steps? And then the use cases for this are also like endless. Here's actually the same use case we built as an app, but here there's no app, and we just use, so the sealed bit RFPs, right? Request for proposals. So here we don't have an app, we just use the GitHub MCP and the Shutter MCP from within the IDE, right? And we just tell it, can you please encrypt our proposal to this RFP and submit it on Git. Let's say the company or DAO or whatever who has issued the RFP has done so on GitHub. That actually happens. We've seen that in the past, right? And you can, in one prompt, essentially encrypt and submit. So it calls the Shutter MCP to encrypt, and then it calls the GitHub MCP to submit to the repo, right? So it feels very magical to do all this in just one prompt. Another fun one here is we have this use case where we say, if you have a bug bounty, if you found a bug bounty, but let's say the project that you have a responsible disclosure thing, and you want to disclose the bug to that company, and obviously you don't want to publish it because then it's exploitable, right? But I think there's many cases where those companies aren't taking it seriously, and they say, it's not that bad, we don't act on it, or we delay action on it. So here you can kind of, it's a little bit of a fun way, but not sure if it actually is a good use case, but I think it would be a fun way to say you could threaten and enforce the action on this bug bounty, because you would time lock encrypt the entire kind of disclosure, and you would say it'll be released in 2 weeks, so the project really has to take action, right? And again, just this one prompt, essentially time lock encrypted, and then it's just using the Shutter MCP from within your IDE VS Code in this example. So if you need any of this, essentially, if you're interested in kind of this distributed form of encryption, talk to us. Also, if you're working on a chain, or if you're interested in having the Shutter API deployed on your chain, that's also something that we'd love to talk about. We're also adding these event-based decryption triggers to Shutter, so then it won't just be time-based, but we can also have generic kind of trigger conditions. So that's an upcoming feature that's going to open up a lot more use cases potentially also kind of in the privacy field as well. But yeah, so thank you so much, and I think.
ありがとうございました。Thank you very much. それでは続いてのスピーカーご紹介いたしましょう。続きましては、ヨルク・ベルナー・レオンハルトさんです。Now, we'd like to invite our next speaker, Mr. Jörg Werner Leonhardt. Mr. Jörg Werner Leonhardt, the floor is yours.
Good morning, and thank you all for staying with me. I know it's lunchtime, so you're probably hungry. But before you head out for lunch, here's some food for thought, and hopefully sprinkled with some inspiration for dessert. But yeah, after I'm done, you're allowed to leave. I don't know how good the translation is. I always have I always get the thought that the faster the speaker is, the worse the translation gets. So I'll try to speak slowly, and if I go too fast, just wave me down. Okay, so I'll try to stick to my prep. Okay, so here we go. So when I first got involved in the Ethereum ecosystem, it was actually the ethos that captured me. So it's stuff like trustlessness, you know, that there are no intermediaries, that we have smart contracts that actually enforce rules, that the blockchain is open and unstoppable. Also that anybody could build, that you didn't have to ask anybody for permission, that what we built, the code is public, it's forkable, it's composable, and also that it's not a walled garden. It's more like, I don't know, a big box of Lego bricks, and that anybody can take out some of the bricks and put them together, whatever you like, and you can build new stuff from it. This is stuff that I liked. Also that in this ecosystem, there is no single party to control access or rules or the infrastructure, that the validators are spread out globally, that the technology is built to survive resistance from governments or corporations. What I really liked is that the early devs were not in for the money. They were here because they wanted to build something new, the next internet, to be used by anybody, totally open and free. Ethereum is supposed to take no sides and to play no favorites. It's to be used by anybody. It could be a bank or just a DAO. It's a protocol that anybody can use to transact, interact, cooperate, and innovate. Banking the unbanked was a very strong narrative in the early beginning. I'm no OG. I only started full-time in the space in 2018, but I have seen some changes since then. Let's be honest, how many of us actually rely on centralized RPCs for everyday use? So we built an ecosystem that celebrates trustlessness, and then we quietly inserted a black box right in the middle. Doesn't this contradiction bother you? RPCs aren't evil. They're useful, but they reintroduce the very risk that we tried to remove. Single point of failure, censorship, data manipulation, opaque failure modes. If Ethereum is the operating system for a credible neutral internet, why are we outsourcing truth to third-party servers? Vitalik tried to invigorate us all to step up and make Ethereum a cypherpunk again, or in his own words, to make at least a part of the Ethereum ecosystem actually be the permissionless, decentralized, censorship-resistant, open-source ecosystem that we originally came to build. I won't be able to fix the ecosystem in a 20-minute talk today, but at least we'll explore one important building block for the ecosystem that we originally came to build. So you probably remember the part of the ethos that resonated with your innermost values. But what realities are we actually confronted with each day? We all keep seeing the same patterns. There are teams that preach decentralization, and then they ship products that depend entirely on centralized RPCs or data from index servers. We have wallets that ask an RPC, what's the balance? Or you have dApps that ask, did the transaction land? What's the receipt? What's the log? There are analytics, notifications, is final checks, and that's all offloaded to endpoints that we don't control. And then when it breaks, we say the blockchain is down, when actually we mean that our pipeline to it is broken. Here's the honest truth. For many users, RPC responses are the de facto blockchain. That's not evil, but it's just too fragile. It's a classic convenience trade-off, but it collides head-on with Ethereum's original promise. So naturally, what would you do? You'd explore the obvious temptation and just think whether it would be easy to make light clients even lighter, to make it possible for more use cases to just spin up a client. That helps, but it doesn't erase the core problem of continuous sync, network chatter, and it's still too heavy to run on constrained environments like mobile, embedded, browsers, or IoT. And it doesn't address the human reality. Devs still reach out for the easiest solution, an JSON RPC call if there's no drop-in alternative. And guys, you know, that's just the truth. You probably do it yourself. Well, then we have to pivot our thinking. If we don't want to think smaller, we should prove smarter. What if the device doesn't hold history, doesn't gossip, and doesn't download the state of the whole entire world? What if it pulls cryptographic proofs on demand from any source, even an untrusted one, and verifies it locally? You can fetch data from a CDN, a friend's laptop, even a hostile server or random RPC provider, as long as you verify the proof yourself. That flips the model. The remote server is then just a dumb data courier. Truth comes from the math on your device. There are a couple of hard questions that we have to answer, though. How do we verify execution without a trusted full node? Or how do we establish consensus truth that a given block is actually valid without replaying long committee transitions? How do we make this run in the real world in a wallet, a browser tab, or a microcontroller? Well, these thoughts and the answers to that actually led us to Colibri with proof-based execution verification, succinct consensus verification, and a tiny embeddable core. What's at stake is more than convenience. It's about restoring user agency, making verify locally the default, not an exception. Imagine a world where every wallet, every dApp, every IoT device can say, we don't ask you to trust our backend, we ship proofs that you can check yourself. That's the world that we are building towards. That's why we built Colibri. So, Colibri in a one-liner. It is a stateless, proof-based, ultra-light client that runs anywhere, mobile, IoT, or browser, so wallets and apps never have to trust RPCs. So we ask you to don't trust, verify. Ethereum was originally designed so that your app would connect directly into the network of nodes. You can fetch your data directly from the chain, and by doing that, it would be decentralized, it would be trustless, there's no censorship involved, and you have full verification. This is the ideal world. That's what we actually think is going on, but then we have the reality. Most wallets and apps don't do that, but they go through a centralized RPC. And the RPC then becomes the bottleneck, one service to rule them all. However, if the RPC lies, if it censors, if it fails, your app is totally blind. What can we do about that? The way forward is not to get rid of RPCs, but to change the role. Instead of asking RPCs to be the source of truth, they become just data providers. Alongside them, you would add a proof provider. Your app then checks information plus proofs. The result, the whole thing becomes trustless again, and the verification happens on device. Or you could also put the prover locally on the device. Either way, the key is this: you're no longer trusting RPC responses, but you're verifying cryptographic proofs. So in the end, don't trust, verify. To run such a stateless client, you don't need to interact with a peer-to-peer network or to store the state of the chain. However, you need to talk to an RPC provider to fetch the blockchain data itself, and then you'd also need proofs of the execution and of the consensus layer. And in case of an L2, you would also need a rollup proof. And these proofs would either be also provided by an RPC or by a standalone proof provider, or you could also create those proofs on your device itself. Colibri on your device would then verify those proofs locally. So the device, not the RPC, decides what is true and what is not. So to wrap this up, Colibri offers you an ultra-lightweight, stateless, trustless, proof-based multi-chain client that enables you to not trust, but verify. So why does it matter now? This is not a whiteboard fantasy. Colibri is already running where it needs to run. We're going operational on Ethereum mainnet and Gnosis with other EVM chains and L2s in scope. The pieces exist, the UX is ready, the gap, the verifiability gap, can finally be closed. Don't trust, verify. Now, zoom out with me. A world where every device, phones, browsers, hardware wallets, IoT devices, microcontrollers, or even AI agents, they're able to do the verification themselves. IoT, for example, would stop phoning home for permission. IoT checks cryptographically facts locally. Web applications become truly trustless, not because your backend is truly honest, but because users don't have to trust you anymore. Mobile devices, by the way, would never be able to run a client that needs to stay in sync. But with Colibri, you fetch data only on demand. This is the next step in decentralization. Not just decentralized consensus among validators, but decentralized verification among users. In that world, you can still run RPCs and indexers, but the role has changed. They become data providers and not arbiters of truth. If they lie, your device can detect it. If they censor, you fetch from somewhere else. If they go down, you're not stranded because proofs can come from anywhere. Colibri is not another server you have to trust. If the missing client layer that makes don't trust verify a default experience for wallets, for dApps, and devices, That's the future I want to live in, and hopefully that's also the future that you can live with. That's why we're building it. Okay, let's talk about some examples, what it would actually look like. Let's take, for example, a wallet. Today, the wallet would ask an RPC for balances and recent transactions. With Colibri, you request proofs along with the data, independent of their source. Your app verifies them locally. The user doesn't just see a balance, but a verified balance, derived from Merkle proofs tied to real block headers that you validated through consensus proofs. The UX might be the same, but the security model is not. You're no longer saying, trust my RPCs, bro, but trust the proofs that your device just checked. Or think about, here you go. Or think about last week's NPM incident. A malicious package slips into your pipeline, and suddenly your wallet's signing flow touches code you did not expect. With Colibri in the loop, you can simulate and verify a proof-backed state before the user signs, and most importantly, you can compare the signed transaction with the original before you publish the transaction to the mempool. If anything is off, if there's a difference in storage slot, if the allowance changed, or if the send address has changed, and that's what unfortunately happened last week, you don't publish the transaction anymore. So, don't trust, verify. DeFi front ends today mostly say, trust us. This is your APY, the TVL, your position value. With Colibri, a frontend can say, don't trust us, verify. The app ships proofs for position balances, receipts, events, and the user's device verifies them locally. This doesn't just protect users, it differentiates products. A verifiable UI outcompetes Trust Me UI. And the whole thing extends beyond phones or laptops. A smart lock could check on on-chain access list without an on-chain access list without trusting a gateway. A smart meter can verify a pricing update before acting. A machine can accept a payment or a key revocation only if the proof checks out on board. An AI agent can check balances, prices, and simulated outcomes before acting in your behalf or fully autonomous. No cloud required, no RPC assumptions, just cryptographic verification at the edge. Ethereum was never about trust me. It was always about don't trust, verify. Let's bring that back together. Now, if you want to dive deeper, everything is open. Here's the white paper, the spec, and the GitHub repo. Be so free and scan the QRs, review the docs, and try out Colibri yourself. We're asking for your feedback from wallet builders, from dev teams, and infra devs. We'd love to hear back from you, get your feedback, your experience, and see what interesting use cases you want to secure by real proofs. And also please join the conversation. Follow me, follow the official Colibri account, or if you prefer the spicy takes, just follow Colibri's ill-tempered cousin with an attitude, Colibro. By the way, if you want to learn more about last week's NPM attack, my friend and colleague Stefan, right here also in the yellow shirt up front, will talk about that attack on Friday, 11 a.m., also here on main stage. And he'll also talk about trustless Ethereum also on Friday on main stage at 11:50. So please also join the conversation right then. Now, thank you for listening. We'd love to work with teams who want to make verifiability a first-class UX feature. Talk to us after the session or also somewhere around here. You'll see us with the yellow shirts. And let's build apps that don't rely on blind RPC trust anymore. Thank you.
ありがとうございました。